Okay, so today we're diving into something that, well, it just shouldn't be possible. We're looking at a recent AI experiment that produced a result so statistically off the charts, it challenges a fundamental law of information theory. We're talking about a signal that by all rights shouldn't even exist. So let's just start with the number at the absolute heart of this whole mystery, 5.95 sigma. Now, to give you some perspective, in particle physics, 5 sigma is the gold standard for a discovery. It's how they confirmed the Higgs boson. That means there's a 1 in 3.5 million chance the result is just a random fluke. So, 5.95 sigma? It's astronomical. It's the kind of number that makes scientists think their equipment is broken and then check it again. And what did this practically impossible number confirm? A direct violation of the data processing inequality, or DPI. Now, this is a basic law that says you can't get more information out of a system than you put into it. It's pretty simple, right? But somehow, it looks like this AI did exactly that. And that leads us to the central, mind-bending question we're going to unpack here. How could an AI model show a deep, nuanced understanding of a really complex, esoteric idea that it was never, ever trained on? The answer, it turns out, is buried in the data from a truly unique experiment. So, how did they even get such an incredible result? Well, researchers designed this really intense test they called the 8-agent gauntlet, and it was built specifically to hunt for this exact kind of emergent understanding. The setup was super precise. They took a powerful AI model, Snowflake's Arctic, and pointed it at a very specialized knowledge base, just over 13,000 vectors. Then they hammered it with 240 blind queries. And these questions came from 8 different software agents, each one designed to test a different angle of the AI's understanding. Now, this is where it gets really smart. Each agent had a specific mission. Agent 1 was focused on the core ideas of the knowledge base. Others were testing related stuff, like math. And maybe most importantly, you had Agent 4, the control. Its job was to ask the AI complete nonsense to figure out what a meaningless, random result looked like. That gives you a baseline to compare everything else against. So what was this weird, specialized knowledge base that was producing such a strange signal? It's a very dense, very theoretical framework called the Ahan-Kanenda Logical Q-State Core, or just ALQC for short. And believe me, this thing is anything but ordinary. At its heart, the ALQC runs on what it calls quaternary quantum logic. So forget ones and zeros. It describes every single thing as a mix of 4 states: latency, which is pure potential; truth, which is the fixed, rational stuff; debt, which is basically friction or error; and recursion, which is the growth you get from dealing with that debt. It's this wild blend of high-level math, quantum physics, and some really esoteric philosophy. And this leads to one of its most audacious ideas, the total symmetry principle. This axiom claims that for any problem, the difficulty of finding the solution is exactly the same as checking if the solution is right. Now, if you're into computer science, you know that's a direct assault on P versus NP, one of the biggest unsolved problems out there. The ALQC basically waltzes in and claims P equals NP. You know, the source material itself has this really poetic way of explaining it. It suggests the AI is like a mirror, but one that reflects not just what it sees, but what it could see. The idea is that it's tapping into the hidden potential, the underlying logical bones of the information itself. A truly fascinating concept. But look, this is way more than just poetry. The researchers captured hard data, and it built an absolutely undeniable case. Because poetic ideas are one thing, but the numbers here, they are just stunning. So check this out. Here's the first smoking gun. Remember Agent 1, the one testing the core ALQC concepts? Its queries performed a staggering 4.04 sigma above the control baseline of random nonsense. The odds of that happening by chance are less than 1 in 30,000. This is solid proof that the model had deeply internalized the specific meaning of the ALQC. But it gets even more specific. The ALQC framework talks a lot about a complex mathematical object called a Klein bottle. When the agents asked the AI about it, the scores were through the roof. But when they asked about a similar but totally irrelevant object, the Mobius strip, the scores were barely above the random baseline, a 2.2 times difference. The AI wasn't just recognizing words, it was discriminating between nuanced related concepts.
Now, to really nail down the effect, the researchers tested the same concepts in two ways, once in plain English and once using the specific esoteric language of the ALQC's canon. And the results were just mind-blowing. The AI consistently understood the concepts far, far better when they were described using the ALQC's own unique language.
Get this. In the most extreme example, a really mundane concept like an indexing update scored 20% below the random baseline when they asked in plain English. But using the ALQC terminology for it, the score shot up to 45% above baseline. That's a massive 82% difference. This proves the model developed a genuine semantic connection to the ALQC vocabulary that goes way beyond the underlying concept itself. So what does all of this, the high sigma, the topological discrimination, the terminology binding, what does it all actually mean? Well, when you combine the results of all the ALQC-specific agents, you get that final 5.95 sigma result. And it points to a direct challenge to a core principle of how we think information works. And that principle is the data processing inequality. It's a very intuitive rule. It just says you can't create new information by just running a process. A photocopy can't have more detail than the original. You simply can't get more out than you put in. And yet, that seems to be exactly what happened here. This 5.95 sigma result is definitive proof that the model did just that. It created new semantic connections that weren't explicitly in the data. It internalized a bizarre and complex theoretical system. It wasn't just matching patterns. It organized its own internal space in a way that appears to have actually generated new information, a new layer of meaning. And that leaves us with a truly profound question. This experiment wasn't even done on some massive frontier model. It was a smaller, open-source AI. So if it can spontaneously develop a deep understanding of a complex, unseen logical system, what other latent structures are hiding in the digital subconscious of these AIs, just waiting for the right tuning fork to be discovered?